I mean, if you haven't seen it before, then this is a good time to learn something new. And if you've seen it before, then just use it as a refresher. Basically, what we do, we're going to transition from if we have a point expressed as an ordered pair in x and y in the Cartesian system, then we're going to express it as r theta, where r is a certain radius and theta is an angle measured from something called the polar axis. So in terms of vocabulary, we look at the pole. We have the pole. Well, the pole is basically the center of a certain circle. So a pole, let's say, is a reference center of a circle, a reference point, usually is the center of a circle. Conveniently, we place it, if we transition from Cartesian to polar and from polar to Cartesian, then the pole will be the origin, 0, 0. So usually it's the center of a circle placed at the origin, which will be xy equals 0, 0. And then there is something we call the polar axis. The polar axis is our reference half line or reference ray that allows to measure the angle. So this will be a reference half line. with okay, I think I'm still recording, so that's okay. With the endpoint at the pole, and usually it's coincide with the positive half of the x-axis. So we have the pole, which is essentially the origin, and the polar axis, for our purpose, is the positive half of the x-axis, and we use the polar axis to measure the angle theta in the pair r theta firm. Okay, so the way it works on a Cartesian system, if we pick up a point pxy, like let's say in the first quadrant, so this is in x and this is in y, and this is the point xy. Okay, how it is in the polar system? Well, in the polar system, the equivalent, this is the pole, the polar axis will be right here. So this refers to theta equals 0. Okay, that particular point will be given by its distance from the pole, and this will be r, and by its angle theta measured from the polar axis. So this will be p in r theta, like so. Okay, so this leads to a conversion. If we want to convert from one system to another, actually before we talked about conversion, one thing that the indicate the difference between the two systems is the following. Okay, the main difference, let's write it, between the system, the coordinate system. The main difference is, while in the Cartesian system, P of xy is defined uniquely, P of xy defines a point uniquely. So, for instance, if I'll say that the point is as the coordinate 4, 3, that's the only way to describe that particular point. On the other hand, uniquely, so this is the emphasis on uniquely. On the other hand, P of r theta does not. It does not define a point uniquely. For instance, if you look just at this point P of r theta, if I'll go another round if I'll go one more revolution, I'll be at the same point. I'll have exactly the same point. Or if I'll go in the negative direction, okay, if I'll go negative theta, I'll be at the same place. So it's then to reason that this particular point can be expressed more than one way. Go ahead.
For polar coordinates, is it just any angle at any point on a circle, or does it have to be that angle from the positive x-axis?
The angle is always measured from the polar axis. The polar axis, we chose it to be the same as the positive half of the x-axis.
So we can have another angle past that theta.
Yeah.
Another angle that's the same it's the same value, but it's just past it.
No, it won't have the same value of the angle. It may have the same radius, but not the same angle. Okay. For instance, the point 0, 2 in Cartesian system will be r equals 2 and theta equals pi over 2. The point 0, negative 2 will be r equals 2 and theta equal either negative pi over 2 or 3 pi over 2. Let me give you a little example. Okay, for instance, let's pick up a point on the system that looks like this. Let's say this is the Cartesian system, and I'm picking up a point 2 and 3 pi over 2. Okay? The point 2 and 3 pi over 2. Well, let's first measure 3 pi over 2. Well, this will be 2 pi over 2 right here, so we go, 3 pi, 4 pi over 3. Let's go with 4 pi over 3. Okay? So we'll go pi over 3 past the pi, so we are right here. And if r equals 2, so this is theta equals 4 pi over 3, and this is r equals 2. So this point is 2, 4 pi over 3, right? On the other hand, I can go in the negative direction, like so, and the angle will be theta equals negative 2 pi over 3, right? So this point, I can write it as 2, comma, negative 2 pi over 3. And it is the same point exactly. Okay? Here's another thing. I can also go, let me change it another color. Okay, I can go only pi over 3, but I let r to be negative. Okay, so this is still r equals 2, and this is theta equals pi over 3. But in blue, I can say this will be r equals negative 2. So another way to express this point would be negative 2 and positive pi over 3. Okay, so we go only pi over 3, but instead of going forward with r from the origin, from the pole, 2 units in the direction of pi over 3, we'll go backward in reverse, and we come up with the same position. So here is one point expressed in 3 different ways using polar coordinates. And there are more. I mean, I can go 2 and 4 pi over 3 plus 2 pi. That will be one more revolution around the pole, right? I'll be in exactly the same position. So different ways to express one point. That's why we said that with this system, we don't we do not define a point uniquely as we do with Cartesian system. All right.